Once you have the image, you want to store it in a repository. I mean, it's fine if you're for your development, you just keep it for yourself, but eventually you want to run it somewhere. So it needs to go into a repository. Docker runs in itself a repository called Docker Hub, and Docker by default assumes that you put stuff into that Docker Hub. But you can also run your own repository. So, for example, the foundation runs its own repository. You just have to tell that then in the image building, you don't want to get it from Docker Hub. You want to get it from this repository. So it's slightly more verbose in terms of length, but it's very common to run your own repository. Nevertheless, for testing and figuring out something, Docker Hub is probably the preferred destination. It has many millions of images on it. 8.5 here was the last time I looked. Might be bigger by now. They are not all the same quality. So there's research going on here on what are good images, because anybody can put images. I have 10 images on Docker Hub, and you can use them if you want to. But why would you? I mean, you can do some research. Maybe you want to look for an image that does something already, and you base it on that. So it's a way to distribute software, right? The Docker image. So there are many on there, like we saw, many millions. Some of them are called official. Those Docker builds by themselves, and they are kind of good choices to base your own images on. So you can see here, for example, Ubuntu Alpine is a pretty popular image. You see my Python image there. There's also an Hello World image, which you maybe want to test to see if Docker works at all. There's MongoDB images and things like that, MySQL. So those allow you to relatively quickly compose things and get going in a very quick way. Like I said, not all of them are built in the same quality. So once you upload an image, it's there. And if it's not maintained, it will eventually have vulnerabilities inside, right? So vulnerabilities are found all the time in software. So if I uploaded my image a year ago and Python had many vulnerabilities at that point in time, well, sorry, Python did not have any vulnerabilities at that point in time, but that version that it is referenced has now a decent number of vulnerabilities, then that might not be the best choice for a software for you to base your software on. So this research here shows that many of the images have vulnerabilities. Most of them, I think, just because they are not frequently updated. Because when I upload that image, that's basically the version that I am leaving there. If I don't re-update it once a month or something like that, it will tend to become older and contain more and more vulnerabilities. There's also malicious images on Docker Hub because, well, people that want to make money through that, they've seen that people, other people just download things from Docker Hub and run it because they want to reach something. So I think these cyber criminals believe I could embed if I make an image that is popular and that many people will base their stuff on, and I embed, for example, some Bitcoin mining software or so, then that will just run. So it's a cheap way to get some crypto mining done. So here's some research of what you can find in there. Malware could be embedded, so this could actually control your machine through that. I think, it's a pretty normal case that when something becomes very popular, it will get abused by certain parties for their own purposes. So Docker Hub is great. when you download, when you build an image and you base it on something that's on Docker Hub, take a look what you're doing there. Maybe the official images I think are pretty trustworthy. The others you have to do your own research and see whether that's useful or not. And like I said, there's many images there. Companies are using it to say, oh, I have a new product. One of the easy ways to try it out is just make a Docker image available. Then you can just run it. You don't have to install anything. And afterwards, it has not, it's not on your machine anymore, right? It's a Docker image. So that's a really nice feature. But when you download these things, take a look at where they come from, kind of shoot for the official copies, and then you should be okay. Docker offers some vulnerability scanning capabilities in their product. So the Docker Hub is free for kind of home use. If you want to use it professionally, you have to pay for it. The limitations will make you pay for it after a while because you cannot pull that many images from it in the free version. And Docker Hub also does kind of vulnerability scanning in their paid version. The command line Docker that we're using also has vulnerability scanning built in, but again, it has not volume capabilities that will allow you to do this in a scalable way. Does that make sense? Docker Hub, images, repositories, how to base them on. Here's a scan of an older image that I have, and you can see after, I don't know, roughly a year, I had 500 vulnerabilities in there. Yeah, exactly. It accumulates quickly. Fortunately, on line 21, 22, it also tells me how to fix it. So what they're saying I should do is download the newer Python version and then rebuild my image, right? Then I would get like a new package and then upload that image back to Docker Hub, right? So it's a good practice. So I guess the corollary is you need to figure out what images you trust in a production environment. Frequent rebuilds are good. I think CI/CD systems do one piece of that because it's my code and it will get rebuilt. But you also need to figure out what image am I basing this on and who managed those images, kind of the base images. At the foundation, SRE manages those. So it's a little bit different from this free-for-all, just download an image from somewhere, make your stuff work, give it to us, we run it. That's not how the foundation handles it. Eric, question?
Yeah, I just was, and if you're going to talk about this later, then that's fine. Are you going to talk about, or do you guys have something in place that sort of keeps this kind of thing up to date automatically? So, or does it happen like between releases before you do a release? Do you update your images before? And just right. Thinking in the sense of, you know, a no-touch environment where your systems stay up to date.
Right. Yeah. So I guess so. Yes, we do this, but it's not automatic. So Docker doesn't offer you an automatic mechanism, and Kubernetes also does not offer you an automatic mechanism. So you have to figure out how to do this. And there's probably products out there that do this, but for us, it's our build system that does it. So we do not allow developers to use any image that they want, but we curate a set of images. So we have like images for Python, for Node.js, and PHP, and Go, let's say, right? 4 of them in different versions, and we maintain them. And then that kind of solves the very base image issue. But I don't know if you remember this when I showed the Docker file. I was installing some libraries there with pip, which is a Python manager. So there's that question, right? How do how complete is your image. So for example, the Python image that you download from Docker Hub is very complete. So you download that thing, pretty much any Python program that you can think of will just run, because all the libraries are there. So that's why it's so heavy. It's like a gigabyte or so. Our Python image is like 200 megabytes at the foundation. Because it doesn't have all these libraries in there. So what we found that it's a good base for most of the stuff that we're doing. And then developers need to download their libraries. If we figure out that these libraries are used everywhere, we would probably come out with kind of an intermediary image that would make that go away. But it's the responsibility of, let's say, the build system to build up-to-date images. And most of the time, the base image does not change. Let's say we change it maybe once a month. And we have a security team that is aware of Docker images and the implications of that. Does that make sense?
Yeah, it does.
Okay, so let's take a quick break for 5 minutes, and then we'll take a look at lab 1. Well, we'll run a simple Python application on the machine itself, then run it under Docker and see how that workflow works out. Okay, so 5 minutes, 15 after, or yeah, I don't know where you are. So for me, it's 15 after. We'll be back.
Want to become a software engineer at Google? You can, like thousands of our students. You just need to learn from those who've already cleared FANG interviews. At Interview Kickstart, our interview prep courses are developed and taught live by 150 plus instructors from Tier 1 companies like Google and Facebook. Our courses are tailored to help you crack software engineering domain interviews, including back-end, full stack, machine learning, embedded systems, data science, and more. To learn more, book your free webinar slot today